All right, so I'm just going to go over all these questions just to make sure that we're all on the same page. When I go through some of these, though, remember yours could be different, especially when we get to like where there's multiple steps and multiple things going on. You don't have to do it the exact same order, the exact same way that I'm doing it. All right, but for this first one, we are just multiplying. So when we're multiplying our rule, the product rules, we add our power. So it becomes 9 plus 22, which is equal then x to the 31st power. So when we're multiplying, we just add our powers. And remember, what's happening is some of you are like now forgetting to multiply regular numbers. These are exponent rules, exponent laws. So we're only applying these to exponents. All right. When we are dividing, quotient rule, it says to subtract. And one of the ways I was trying to remember, because since 5 minus 1 is equal to 4 and 1 minus 5 is negative 4, they're the same number but different signs. Rather than having to apply multiple rules, we just ask the question first, where are there more at? And then we subtract from there. So even though the rule does say it's a numerator minus a denominator, we can, since we get the same number as far as 4 and 4, just different signs, we can change that to make it so we don't have to go through multiple steps. So I asked myself, where are there more y's to begin with? Well, there's more in my numerator on top. So that means that my answer is going to end on top, because if I'm canceling these out, there's not enough on the bottom to cancel all the ones on the top out. So now we subtract. That's our rule with our quotient, 15 minus 5. So that means y to the 10th power. All right. There's different ways, maybe not those first two, but there's different orders that you can do things. And it's up to you of how you want to do it. But when I show you this, I'm only going to go through it the way I do it. All right, here we have 3x to the 0 power, and here we have 5x to the 4th power raised to the 0 power. You notice this is inside of parentheses. This one's not. So here, only the x is being raised at 0 power. So this is the same thing as 3 times x to the 0 power. And our rule with 0 power, anything raised to 0 power is 1. So this is 3 times 1, or 3. A lot of you are writing 0. That means make sure we're not really applying the 0 power at all correctly there. And some of you are just writing 1 overall. There's a huge difference when it's written in parentheses versus when it's not. And since this is written in parentheses, that means all of it is being raised to 0 power. So this is just 1 as our final answer, because both the 5 and the x are being raised to 0 power. Here, only the x is being raised to that 0 power. All right, number 5, we have power to a power. Now, this is where some people are going wrong, because our power to a power rule is we multiply. So some people are saying, oh, well, this is 2 times 4, which is then equal to 8. But you're no longer applying our real rules that you guys have learned before. It's only our exponents are we multiplying. So this is saying 2 raised to the 4th power. And 2 raised to the 4th power is 2 times 2 times 2 times 2, or 4 times 4, or 16. So when we have coefficients, we're applying the normal operation that's happening. 2 is being raised to the 4th power there, so we raise that 2 to the 4th power. Now here we have x to the 5th being raised to the 4th power. And our rule with power to a power is we multiply. So then here we would get x to the 20th power. All right, so just because the rule says we multiply doesn't mean we just multiply a power with the base. It's our exponents that we're doing. These are the exponent rules, the exponent laws. All right, so same thing here for this number 6, number 7. This comes back to the one that we just talked about with 4 and 3, is you have to be able to understand the difference between when something's in parentheses versus when something is not. So in this number 6, the only thing being raised at negative 3rd power is x. So that means to get rid of our negative, we know we're taking the reciprocal. You say you love me, now you flip it like reciprocal. So x to the negative 2 is equal to 1 over x squared. 1 over x to the negative 2 is equal to x squared. So we're flipping that, wherever that x or that variable or that number is at, we're just rewriting it in a different spot of its fraction. We're taking its reciprocal. So since this right now is written in the numerator, in order to get rid of that negative exponent, I need to write it in the denominator. And since 2 isn't being raised at negative 3rd power, nothing's happening to it. So the 2 remains where it's at in the numerator, and it becomes 2 over x cubed. For this one, though, everything is being raised to that negative 3rd power because it's in parentheses. So if I want to make this positive, the first thing I'm going to do is I'm going to flip my problem that's on the inside. So I have 1 over 3x to the 4th being raised to the 3rd power. So by flipping the entire fraction, it's changing that entire power to a positive. So now I have, well, we can say 1 cubed, but that's just 1. And then I have 3 cubed, which is 3 times 3 times 3, which is equal to 27. And then I have x to the fourth being raised to the third power. We multiply and get x to the 12th. So we can do that by flipping to make it negative. Or we can also distribute that negative power in like we did in class the other day. And since this 3 is understood to have a power of 1, it becomes 3 to the negative third power because 1 times negative 3. And 4 times negative 3 is negative 12. And now we can flip them individually and say, all right, well, if I want to make this one positive, that 3 needs to drop to the bottom. If I want to make this positive, that x needs to drop to the bottom. And since everything moved, I need to remember that I need to have the 1 in that numerator. Otherwise, I can't tell that they dropped to the bottom anymore. And 3 cubed is 27. So it becomes 1 over 27x squared, or x to the 12th power. Doesn't matter which way you do it. It's up to you. We get the same answer either way. And that's why I mean that when we're solving these questions, you don't have to do it exactly like I do. Since there's multiple steps, you kind of have a little bit more freedom. All right, here I want to get rid of this negative, so I am just going to take the reciprocal on the inside. So that flips to 2/3, and by doing that, that makes that power positive. So now I'm going to go ahead and square everything. This is the same thing as 2/3 times 2/3. And when we're multiplying our fractions, we know that we're multiplying our numerator with numerator, which is 4, and denominator with denominator, which is then 9. That looks like a Q, which is then 9. So this is 4 over 9. Or we could have just said 2 squared over 3 squared, which still gives us 4 over 9. All right, so for number 9, this is where some people are struggling with as well, is these coefficients, some people are just subtracting it. Remember, when it's coefficients or numbers, we're actually performing the real operation that's there. So we're thinking, well, 25 over 15, how does this reduce? They're both divisible by 5. So it becomes 5 over 3. So I like to just get my fraction started. Now I'm going to move on to the x. Well, here I ask myself, where do I have more to begin with? I have more x's in my denominator, so that means when I simplify this, it's going to end there. So I can do 12 minus 8. And since, because I had more there, and 12 minus 8 is 4, so that means I will have 4 left over. And then I'll move on to the last one, y's. Well, where do I have more at? Well, I have more y's in my numerator, so they'll remain there. And 15 minus 3 is equal to 12. So you see, when you're doing it this way, we're always just doing it. We don't have to follow the rule exactly like it is. We're kind of skipping a step by doing it this way. But we can just do the larger minus the smaller, and wherever that larger was, it's where it's going to have to end up. All right, number 10. Here's the same thing. The first thing I'm doing is multiplying my coefficients. So some people might see that negative 9 and think, oh, well, I need to flip that negative. It's not a power. So we will do 8 times negative 9, which is then negative 72. Then we'll move on to our x variable. Well, when we're multiplying, we are adding, and negative 14 plus 4 is negative 10. So now I have x at negative 10, and when I see that, I'm like, okay, I know I'm going to have to do something later on with it. I have y to the 6 times y squared, so we're adding, and 6 plus 2 is equal to 8. So this will give me y to the 8th power. And then our last one, we have z and z, which when there's nothing written there, we're understood that their powers of 1. So that then gives me z squared. We're not done yet, though, because we can't leave a negative exponent. So that means I need to get rid of that negative 10. And since x was in my numerator, I need to write it in my denominator. So it's negative 72, y to the 8th, z squared, all over top of x to the 10th power. This one would be like exceeding at this point. When we practice this more and more, it will be one that I would expect you to be able to do. But for now, that one will be exceeding. All right, number 11. From here, the first thing I'm going to do is look at all my coefficients, 3, 12, and 10. I'm going to reduce them. 3 goes into 3 one time, and 3 goes into 12 4 times. 2 goes into 4 twice, and 2 goes into 10 5 times. So I've reduced all of my coefficients, and I have 5 over 2. Now I'm going to do each one individually. Or I'm going to actually, it's up to you of how you want to do this. But I have 5 and 3 x's in my numerator, and then I have 1 and 8 in my denominator. Once again, this is going to be an exceeding problem, but I'm going to do 5 plus 3. I'll just do it step by step. So x to the 5th times x cubed, that will give me x to the 8th. And on our denominator, 1 times 8, we add them, so it gives me x to the 9th. Here I have y to the 7th times y to the 11th, so y to the 18th. And y squared times y to the 5th is now y, or y cubed is now y to the 5th. So then I will go ahead and finalize this answer. So we have 5 halves still. I have more x's in my denominator, so I know it's going to end up there. And 9 minus 8 is equal to 1. So it's just x. I have more y's in my numerator, so end up there. And 18 minus 5 is equal to 13. So y to the 13th. All right, so for this next one here, we have more 5's in my denominator, so I know that my answer is going to end up there. 5 minus 2 is equal to 3, so it's 5 cubed. And just like the direction said, we are going to be expanding those out because what we're doing next is going back and forth, expanding and rewriting as powers. So this is 1 over 125. All right, almost done. This, we see everything is inside this parentheses. So everything is being raised at 0 power. Anything raised at 0 power is 1. So this looks really, really hard, but it's actually the easiest question, or one of the easiest questions. It's just simply equal to 1. All right, here we have our coefficients of negative 5 times 2. So negative 5 times 2 is negative 10. Our rule is we add our powers when we're multiplying. So negative 8 plus 6 is equal to negative 2. So we have negative 10x to the negative second power. We can't leave this as negative. So since it's in the numerator, we drop it to the denominator. And the negative 10 stays because only the x is being raised to that power. And then our last one here, the star also means that this one is exceeding. But we have negative 3 times negative 8. So a negative times a negative we know is positive, so it's going to give me 24. We have x to the 0 times x to the 4th. Well, 0 plus 4 is 4, so now I have x to the 4th. And we have y to the 5th times y to the negative 2nd. So 5 plus negative 2 is equal to 3, so it becomes y cubed. All of these are positive. I don't need to worry about flipping or doing anything else. All right, so that is it. If you have any questions, email me. Make sure you're practicing. Regardless of what you do in this next assessment, just understand, though, that we will be reassessing this a lot this unit. So you'll have plenty of opportunities to show where you stand. This is just the first of many. If you show me towards the end that you're mastering, then that's what your grade is. All right, it's more about the trend. Are you moving up? Are you getting to that mastery? Or are you going down? Are you going to developing? It's more about the trend. So it's not where we start, but where we end.